So in this video we're going to look at another trig functions graph, and that's of secant. And just like cosecant and sine, which are reciprocals of each other, are related in their graphs, secant and cosine are also related in their graphs. So here you can see I have the graph of secant. Notice I have vertical asymptotes occurring in this particular graph. I have what look like these parabolas scattered about. And I'm going to just lay out for you the cosine function so you can see how these are related to each other. Cosine starts high, it crosses here, it goes low, it crosses again, and it ends high. So if I were to sketch this graph, notice that everywhere my cosine function crosses the x-axis, I have vertical asymptotes, and everywhere I have a maximum or a minimum on the cosine function, I end up with a parabola. So this is similar to our cosecant graph and the way that cosecant and sine were related, in that secant and cosine are related in the same fashion. So their domains for secant, the domain for secant would fall in between the vertical asymptotes as listed here. The range for secant is just like cosecant, where we have negative infinity to negative 1 and then 1 to infinity. And then again, because secant and cosine are both related and cosine's period is 2 pi, then the period for secant is 2 pi. And there's no amplitude. So we'll jump in and we will graph this function here. So we're going to graph 3 secant 2x. We start off by identifying a. So in this case, a is 3 because it's being multiplied times the function, and we'll need that to be able to put a value on the y-axis. The next thing we want to identify is b. b, since b is being multiplied times the variable, b is 2. Our period comes from 2 pi over 2, or just pi. So I'm looking at an interval between 0 and pi, and I want to break that interval up into 0, pi, halfway between is pi over 2, half of that is pi over 4, and on the other side is 3 pi over 4. So these are the numbers that I start with, and since this function does not have a phase shift, we're not adding anything into this variable x, then these are the numbers that I'm going to start with. Again, I'm going to do this over 2 periods, so I want to be able to identify that on my x-axis. So let's go down. We're going to draw it out. Since there's no phase shift, this will be easier to draw, I think. So we're going to go from 0 to pi. So we have 0 and pi, halfway, half of that is 3 pi over 4, and then half on the other side is just pi over 4. So if this is the original interval that I'm going to have, this is 1 period, so I'm going to go in the opposite direction for the second period. Now you could go in the positive direction 1 more period. Either one, doesn't matter. So instead I'm going to add, or subtract really, pi from 0, and I get negative pi, and then I can divide up on the left. So I have negative pi over 2, same numbers really as what I had on the right of 0, which is kind of why I chose it, because it was easier to do. So now I have my 2 periods clearly marked on the x-axis. I need to draw the value on the y-axis, which is at positive and negative 3. And I'm going to go in and I'm going to start by just using dots to represent the cosine function. So cosine is going to start up here on 3. It's going to cross at pi over 4, have a minimum here at pi over 2, it crosses at 3 pi over 4, and finishes at pi. Everywhere my graph crosses the x-axis, everywhere it crosses the x-axis, I'm going to draw an asymptote. So I'm going to continue in this direction, and I know I'm going to cross here at pi over 4. I have a minimum negative pi over 2. I cross at 3 pi over 4, and I have a maximum at negative pi. Okay, so this should be negative pi over 4. Again, everywhere I cross the x-axis, I'm going to draw a vertical asymptote. So all of my vertical asymptotes are drawn, and I'm just left with finishing by drawing my little parabolas. So this is only a half one over here, but I have whole parabolas occurring here at all of these other spots, almost all of them really. And then I have a half of one here. And really that's all it is. It becomes a very repetitive process whenever you're graphing these functions.